Lesson 3.4 is titled Systems of Linear Equations in 3 Variables. A system that has 3 variables must include 3 equations. The solution to the system, instead of called an ordered pair, it's called an ordered triple. You might have something with x, y, and z, or other variables like a, b, and c. We'd write them alphabetical just like we do the coordinates for x and y. Our first example on the right gives us a possible ordered triple solution. We just have to verify. Just like when we verified for graphing, to verify means the system or the solution has to work for all 3 equations. It says determine if -5, 1, 0 is a solution to the system. That means you're going to substitute in -5 for x, 1 for y, and 0 for z. So let's test that first equation. If we take 3 times -5 plus 4 times 1 minus 2 times 0, does that equal -11? 3 times 5 is -15, and 4 times 1 is 4, minus 2 times 0, that does in fact equal -11. The first equation is good. Let's try then the second equation. As we substitute those values into that second equation, we get 2 times -5 plus 4 minus 0. Does that equal +11? This time we're not so lucky. 2 times -5 is -10 plus 4 minus 0. That gives us -6, and that doesn't equal 11. If the solution doesn't work in any one of the equations, it's not a solution to the system. So we would say no, not a solution. For the rest of the examples, I'll give you the system and we'll look at ways on how to actually find the correct ordered triple answer. There are 4 key steps in solving a system with 3 equations. Elimination is going to be the best approach on this because we have to get rid of a column that has 3 different numbers to work with. Therefore, substitution, while possible, is going to be much more kind of intense with work. Try to stick with elimination if possible. Look at the 3 columns of variables. We've got the x column, the y column, the z column. Try to pick a variable that looks like it would be easy to work with to eliminate. Technically, you can choose any column, but if you can try to find one that has numbers that are fairly user-friendly, you should be in good shape. Now, what you're going to do with this is pick 2 equations and eliminate the variable twice. So pick 2 equations, eliminate from that set of column, and then pick 2 different equations and do the same thing. What's going to end up happening is you're going to create a smaller system, and that system will have just the other 2 variables in it. We'll solve that either with substitution or elimination. So at that point, you can solve with either method. Once you get those 2 answers, substitute those answers back into one of the original equations. I know, this seems like quite a process, and it is. Attention to detail is going to be super important as we solve these systems. Let's give the first one a try. You'll need a fair amount of space here. So this is a time where you don't want to try to squeeze work to fit into a small space. You definitely want to use the paper, keep your work organized so that it's easy for you to follow. All right, we have 4x plus 2y plus 3z equals 1. There's our system that has 3 variables. And the next equation in the system, 2x minus 3y plus 5z is equal to -14. And then we have the third one, 6x minus y plus 4z equals -1. As you look at the columns, we have x's, y's, and z's. Now you could really pick any column to work with, but you have to start with one. You have to just decide which column you want to eliminate. So I'm going to say let's eliminate the x column. The numbers are 2, 4, and 6. Those should be pretty easy to work with. So that's just all you do in step 1 is you just pick the variable you want to eliminate. Step 2 is where it gets tricky. What I'm going to do is I'm going to label that top row equation 1. I'm going to label the second row equation 2 and the third row equation 3. So that way as I kind of go through my steps, I know exactly which equations I'm working with. There we go. To eliminate x from the system, you want to just start by picking two of the equations. If I look at equations 1 and 2, I see I've got 4x and 2x. So I could take that second row and multiply it by -2, and it would get -4. That means I'm going to take -2 times everything in equation 2, and I'm going to add that to equation 1. So I'll start off just by making everything in that second row. I'll multiply by -2. That's going to give me -4x plus 6y minus 10z. I doubled everything and changed the sign. On the right, -14 times -2 is positive 28. Now I'm not going to change anything with equation 1. Notice my x column will cancel out. And then we just have to kind of work with what's left over. It's really important to be careful as you copy these down from row to row, as that will definitely change your outcome if we miss a positive or a negative. All right, so in that first column, the x's cancel. We have a total of 8y together in that second column. -10z plus 3z is minus 7z. And then on the right, we have 28 plus 1, which is 29. So we're going to keep this and bring this to step 3 with us when we're ready. So we used equations 1 and 2, and we eliminated x. Now we have to either use 1 and 3 or 2 and 3 and eliminate x again. As I look at the column from the original problem, I notice that the 2 could probably easily eliminate with the 6 if I use equations 2 and 3. To make 2x cancel out with positive 6x, I'm going to have to multiply the entire row by -3. So we're still in step 2. We have to eliminate x twice. We've only done it once. Let's go ahead and kind of simplify that second part so we can move on to step 3. So I'm going to take equation 2 and I'm going to multiply it by -3. Everything in equation 2. And then I'm going to add that to equation 3. So let's see what happens. If I take everything in that second row and I multiply it by -3, I'm going to get -6x plus 9y minus 15z. Make sure you're okay with that step. And then on the right, if I take -3 times -14, that's positive 42. Now if I drop down equation 3, positive 6x minus y plus 4z equals -1. Notice the x's eliminate again, which is what we wanted. We want to eliminate the same variable 2 times. I have 9y minus y, so that gives us positive 8y. -15z plus 4z gives us minus 11z. And then 42 minus 1 is 41. There's our second part for our smaller system. So once you've eliminated twice, we're ready, finally, for step 3. Let's go ahead and take these two and just write them right next to each other. Oh, there we go. So we have 8y minus 7z. Uh-oh, I don't know what's going on here. Hang on, guys. Here we go. Minus 7z equals 29. And then we have 8y minus 11z equals 41. In this stage, some of the numbers are going to get pretty big on us. But it looks like what we could do here is just make one of the rows negative, and then the y's would just eliminate super quick. So let's do that. Let's take the second row, and I'm just going to multiply everything by a negative. So I'm going to change -8y. I'm going to change -11 to positive, and then I'm going to make 41 negative on the right. So I just multiplied everything by -1. When I do that, the y's eliminate. Hopefully we have something decent left over to work with. -7z plus 11z gives us 4z. And then on the right, 29 minus 41, that gives us -12. Oh, I like that. If we divide both sides by 4, we would get z is equal to -3. That seems like that would be easy enough to work with. When we solve this smaller system, we now need to take z and plug it back in either the first row or the second row. I'm going to take it and substitute it into that first row up there. To get y, we would say 8y minus 7 times -3 equals 29. Then 8y minus 7 times negative 3 becomes plus 21 equals 29. And if we move 21 over, we get 8y is equal to 8. This is also working out really nice for us. And if we divide both sides by 8, we get y equals positive 1. We've now solved our smaller system. Then we're on to step 4. The last step we need to do is take our answers for y and z and plug them into any one of the 3 original equations. I'm going to plug it into equation 1, but you could really pick any one you want. We want to solve for x, so I have to start off by just writing 4x. We don't know what x is yet. But if I take plus 2 times y, that's 2 times 1, plus 3 times z, which is negative 3, equals positive 1 on the right. And now we just have to solve for x. 2 times 1 is 2. 3 times negative 3 becomes negative 9. 2 minus 9 is negative 7. To get x by itself, I'm going to add 7 to each side. Running out of room here. We have 4x equals 8. Oh, it's always a great day when our answers turn out to be whole numbers and we take our time and watch our attention to detail. The last thing you want to do to write your answer is write it as an ordered triple in alphabetical order. X is 2, y is 1, and z is negative 3. Let's try another one. We have x plus y plus z equals 3, 4x plus 4y plus 4z equals 7, and 3x minus y plus 2z equals 5. Again, elimination is going to be the best method to start with to try to eliminate the variable twice using 2 of the 3 equations. Last time we chose x, we could choose y. Let's see, or we could even choose z. I like y though. If we look at the first and last equation, it looks like y would eliminate pretty fast. I'm going to start with that one this time. I notice that the first equation and the last equation would already have y eliminate. So I'm going to label them 1, 2, and 3 for my equation 1, equation 2, and equation 3. We'll just do that quickly. When I go to step 2 then, what I'm going to say is just take equation 1, Q, plus equation 3. Let's see, so I have x plus y plus z equals 3. 3x minus y plus 2z equals 5. That's a z right there. The y's eliminate, so we have 4x plus 3z equals 8. All right, let's take a look at what I could do now. Since equation 3 has a negative y, I could multiply that whole row by 4, and it would cancel with equation 2. So I think I'm going to do that next. I'm going to just take 4 times equation 3 plus equation 2. So that would give me 12x minus 4y plus 8z equals 20. And then in equation 2, we've got 4x plus 4y plus 4z equals 7. Okay. So that gives me 16x, sorry. See, attention to detail. 16x. And then plus 12z equals 27. Oh, all right, we've got some big numbers we're going to work with. When we bring it to step 3, I have 4x plus 3z equals 8, and 16x plus 12z equals 27. So it looks like I'm going to have to change either x or z. I don't think it really matters. If I take the x's, I could multiply the first equation by negative 4, and then that would become negative 16. So I'm going to do that and just drop it right underneath. Negative 4 times 4 would be negative 16x. But then I get negative 4 times 3, and I get negative 12z. And then negative 4 times 8 is negative 32. So look what happens here. We saw this before. The x's and the z's eliminate. And on the right, we have 27 minus 32, which is negative 5. That doesn't make sense. That's a false statement. We got the variable to cancel out completely, and the statement that was left over is false. Does anybody remember what that means? We're going to have no solution. For this last one, you get fraction answers, and to make the video reasonable to watch, you're welcome to try this on your own, and I will post the answer key that we do in class so that you can follow the steps. If you have any questions on this, you are definitely welcome to ask.